To draw the translated function, we need to split it up into its x and y changes. So I'm going to start with the y changes. And the y changes are going to be, it's going to be vertically flipped and expanded and then shifted up 3. So we'll do that to every coordinate. We're going to flip, expand, up 3. Flip, expand, so that becomes -2. Up 3 is +1. Flip, expand, so that's -18 plus 3 is -15. Okay, so those are my x transformations. The those are my y transformations. I need to do that to the y. So flip, expand, so -4 plus 3 is going to be -1. -1 times by -2 plus 3, so -6 plus 3 is -3. 5 times 2 is -10, plus 3 is -7. Okay, so I have to apply that to the y's, not the x's. Okay, so now I figure out the change in the x. The change in the x is going to be based on this. Now, I could put it into factored form, so I end up with 1/2 x minus 3, so it's already in factored form, so I know that the transformation is compress by 2, shift to the right 3. Okay, and I can also see that same transformation, okay, when I solve for the other x, because I'm going to have, sorry, this is not a compression, expansion by 2 first, and then plus 3 last. Okay, and I can see the actual calculation, so I'm going to expand by 2 first, and then plus 3. Expand by 2 plus 3, expand by 2 plus 3, so it's going to be 5. Expand by 2, so 18 plus 3. Okay, so there's my new coordinates. So I'm going to scale my x coordinates to draw this graph. So the original graph, I'm going to put my original square root points in. Okay, so I'm going to have my original square root points like that. My transform points, I'm going to have it at x equals 3, -1, 5, -3, 21, -7. So -7 right about here. Okay, 1, 2, 3, 4, 5, 6, 7. There it is. Okay, so there's my vertex. My vertex was at 3, -1. Okay, and then it's going to be looking like that. So there's my transformed function. I've scaled the x-axis in this case, so that's going to be -20 here. The y-axis is still the same, so -10.